Bismillahirrahmanirrahim. We are here for presenting an important technique in chemical industry. Before I start my presentation topic, I would like to introduce my group members. I have SAFIA, NAHEED, HUSSAIN, RANA, BASIT Ali, and ARSLAN, NAZIM. Now the topic of presentation. The topic of presentation is about fractional distillation of crude oil. Distillation basically is a purification technique which is used to separate components of a mixture or to purify an impure liquid. It has generally two types: simple distillation and fractional distillation. Simple distillation is used to separate mixture into pure components, and it works best if components' boiling point differ by at least 75 degrees. On the other hand, fractional distillation is used when components' boiling points are closer together. Unlike simple uses a fractional column, this column may be packed with materials so as to increase the surface area for heat exchange, thus increasing the number of theoretical plates. The more theoretical plates, the better the purification separations. Here, fractional distillation is the more effective purification technique than that of simple distillation. Here you can see from the graph that the graph of the simple distillation is the more scoopy than that of fractional distillation. Now, principle of fractional distillation, there are basically various principles that are relevant to this technique. Some of them are Rolle's law, Dalton's law, reflux, Franks-Queyen, McCabe-Thiele method, theoretical plate, partial pressure, and vapor liquid equilibrium. Theoretical plates, basically any physical device that provides good contact between the vapor and liquid phases present in industrial scale distillation columns or laboratory scale glassware distillation column constitute a plate or tray. You can see its formula. In the formula, Na is the number of actual physical plates or trays, Nt is the number of theoretical plates or trays, and E is the plate or tray efficiency. Franks equation. The Franks equation in continuous fractional distillation is an equation used for calculating the minimum number of theoretical plates required for the separation of a binary feed stream by a fractional column that is being operated at total reflux. You can see its formula also. In the formula, N is the number of equilibrium stages, Zn is the mole fraction of components and in the vapor phase, and Xn is the mole fraction of components in the liquid phase, and P node N is the vapor pressure of pure component. Dalton's law. It states that the total pressure exerted by the mixture of non-reactive gases is equal to the sum of the partial pressures of individual gases. Here you can see the mathematical form P total is equal to P1 plus P2. Here you can also see the formula of mole fractions P1 over P total. P1 and P2 are the partial pressures of each gas in the binary mixture. Now Rolle's law. For a mixture of two miscible liquids A and B, the total vapor pressure is the sum of individual pressures. Here comes its equation. In the equation, PA is equal to NA of liquid into P node of A, and PB is equal to NB of liquid into P node of B. Whereas P node A is the vapor pressure of the pure A, and P node B is the vapor pressure of pure B. And NA liquid is the mole fraction of A, and NB liquid is the mole fraction of B, where Na liquid is equal to mole fraction of A divided by the sum of the both A and B, and Nb is equal to moles of B divided by the mole fraction of both A and B. Azeotrope. An azeotrope is a mixture with a fixed composition that cannot be altered by either simple or fractional distillation. Actually, some mixtures of liquid, because of attraction or repulsion between the molecules, do not behave ideally. These mixtures do not obey Rolle's law, so an azeotrope behaves as if it were a pure compound, and it distills from beginning to end at a constant temperature. Now, types of azeotrope. There are basically two types of non-ideal behavior. Minimum boiling point. Boiling point of the mixture is lower than the boiling point of the either pure components, and maximum boiling point if boiling point of the mixture is higher than the boiling point of either pure component. Now let's talk about some fossil fuels. Generally we have three types of fossil fuels: natural gas, petroleum, and coal. Its appearance and constituents are given in the table. You can see that natural gas appearance is colorless, petroleum has from yellow to dark brown liquid, coal has black solid, and carbon is the main factor in these fossil fuels. Now coal has a solid physical state, and it is not easily stored and transported because of its solid state, and it requires a lot of space to store. And effects, if we talk about its effect of pollution, then we have come to know that large amount of soot and sulfur dioxide is produced is the result of combustion of the coal. Now crude oil is a liquid and a physical state and can flow through the pipe easily, and it can be stored and transported easily by tankers. When we talk about the combustion of crude oil, then we have effect of pollution, and moderate amounts of soot and sulfur dioxide is produced. Natural gas, it is a gas in physical state and can flow through pipes easily, and it can be liquefied under pressure and stored in tanks, and is very low amounts of soot and sulfur dioxide produced as the result of combustion of natural gas. Now crude oil is produced over millions of years by the breaking down of plant and animal remain at high temperature and pressure below the sea. It is composed of a mixture of different hydrocarbons, some with branching chains, some without. The components can be separated by fractional distillation because each compound has a different boiling point. The composition of crude oil. There are a mixture of different size hydrocarbons, where usually it contains a lot of big molecules. You can see the graph. The purple shows fuel gas, blue the naphtha, yellow diesel, red the petrol, green kerosene oil, and the fluorescent denote the fuel oil and the butamin. Obtaining of crude oil. Obtaining basically the main source of the crude oil is our soul. You can see the natural gas, and our natural gas is obtained from the different earth crust, making oil useful. Crude oil itself has no uses. We can get useful substances for oil. This is done in an oil refinery. Need to separate the mixture into molecules of smaller size, and it is based on boiling point, which is called distillation. Now how does it work? Crude oil is pumped in form of storage fats. Crude oil enters furnace and is heated. Hydrocarbons separated at various temperatures. You can see from the diagram that the crude oil is entering into the furnace. Then again in the heating tower, on the basis of different temperatures, different things differentiate. Now fractional evaporate condensed at different boiling point based on the size of hydrocarbons. Fractional are placed in separated containers and further refined if needed. Here comes the main diagram. You can see that the heated crude oil enters from the left side of the diagram into the furnace, in which very 350 degrees centigrade of temperature is applying, and different products differentiate on the basis of their boiling points in gasoline, naphtha, kerosene, diesel oil, fuel oil, and residue respectively. Now fractional distillation of crude separates the mixture of crude oil into various hydrocarbons. Here comes the general here this graph shows some general information about the different things that evaporates on different boiling point during this process. Fuel gas, LPG refinery gas. It has 1 to 4 carbon atoms and its boiling point of 60 to 20 degrees. Gas fuel contains 3 to 4 easily liquefied portable energy source bottled gas for cooking, higher pressure cylinders. Now gasoline, it has 5 to 11 carbon atoms and boiling point of 20 to 60 degrees centigrade, and it is easily vaporized, high flammable, easily ignited car fuel. Naphtha has 7 to 13 carbon atoms in its ring and boiling point of 60 to 180 degrees centigrade, and is not good as a fuel but valuable source of organic molecules to make other things, crack to make more petrol and alkenes. Paraffin kerosene, it has 10 to 16 carbon atoms and boiling point of 120 to 250 degrees centigrade, and it is less flammable than petrol, domestic heater fuel, and jet fuel. Diesel oil or gas oil, it has 15 to 25 carbon atoms and boiling point of 220 to 250 degrees centigrade. It is used as a car and larger vehicle fuel. Fuel and lubricating oils and waxes, it contains 20 to 70 carbon atoms and boiling point of 250 to 350, and it not so easily evaporated, not as flammable, safe to store for central heating oil, quite viscous, and can also be used for lubricating oils, clear waxes, and polishes. Butamin is the most heavier molecule in the distillation. It has more than 70 carbon atoms and a boiling point of over 350 degrees centigrade, and it forms a thick black tough and resistant adhesive on cooling, used as a waterproofing material and to stick road chips on roofs or road surfaces. Now, when the heat is applied down the distillation tower, then first of all petrol, naphtha, kerosene, diesel, lubricants, and butane differentiate on the basis of their boiling points if it temperature increased on the column. Now, petroleum be vaporized in the absence of air at 360 degrees centigrade. If petroleum is vaporized in the presence of air at high temperature, it may ignite and cause an explosion. Here comes the main procedure diagram. You can see that the first step is the obtaining of crude oil from this earth's crust, and then this crude oil is sent to the distillation tower, and in the distillation tower, on the basis of their boiling point, different things differentiate, and as a result their products are go through the market. Product we use daily that are made from crude oil. There is a range of different things that we use in our daily life which are made from crude oil. For example, Vaseline, jet oil, engine oil, petrol, diesel, etc. Here are some references. So that's the end of our presentation. Thank you.